Recording in progress.
Hi students, in this lecture I am going to discuss RC circuits. Let us see. So here we are taking a resistor and a capacitor. So taking a capacitor and a resistor, so connecting to a battery. Initially switch was opened, battery of EMF, take it as E. E stands for EMF, not electric field, it is EMF. Capacitance, take it as C. Resistances are. Initially, capacitor was uncharged. Initially, capacitor was uncharged. Its meaning is no charge on the plates of capacitor. So now we want to calculate, once we close the switch, we want to calculate how charge changes on the plates of capacitor. That means once we are closing the switch, capacitor is now starts charging. So we have to calculate now charge on the plates of capacitor as a function of time. Okay. This is what we call charging of capacitor. Okay. Let us see how to write equation. Once we are closing it, now current starts flowing. That means charge flows in the circuit. Let us take current is now I at one instant, and charge on the plates of capacitor. Let us take it as a Q. That is at one instant. Okay. Now see what we can write here. According to Kirchhoff's second law, if you take loop equation, if you are taken now clockwise across the capacitor, this is now positive and this is negative. So we are moving from high potential to low potential. Okay. So writing here minus Q by C because high potential to low potential. Next, coming to across resistor, we are moving along the current flow, and current flows from high potential to low potential, right? So it is now minus IR. Next, coming to here, we are moving from low potential to high potential. So plus E equal to 0, right? Now in this I is nothing but dq by dt. It is a rate at which capacitor is now charged. Okay. Then see what we can do here. So we can write IR equal to E minus Q by C. See carefully. IR equal to E minus Q by C. That is equal to EC minus Q, right? Upon C. Now take in the place of I dq by dt. It is now dq by dt RC, that is equal to EC minus Q. Okay. Now separate these things. So I can write this as dq by dq upon EC minus Q. dq by EC minus Q, that is equal to dt by RC. Okay. Now simplify this. Now integrate on both sides. Now integrate. When time t equal to 0, charge on the capacitor is 0. at time t charge equal to q. So which we have to calculate. Then see what we get here. It is EC minus q. EC minus q means here we can multiply and divide with minus 1, minus 1, minus 1. Okay. Then see what we get. It is a minus ln EC minus q limits 0 to q, that is equal to T by RC, that is equal to T by RC. Now substitute limits, take minus here. Substituting limits here, it is EC minus q upon take 0, it is EC, that is equal to EC minus q upon EC, q0, that is equal to e power minus T by RC, right? Then see what we get. EC by EC, that is 1. 1 minus q upon EC is equal to e power minus T by RC. So from this, see what we can write. Taking this one to here, it becomes q equal to EC into 1 minus e power minus T by RC. Okay. So this is giving us a charge on the capacitor as a function of time. Okay. Now let us do one thing here. Let us now differentiate this. Then see what we get. dq by dt. That is nothing but current. SR. That is nothing but current. That is equal to EC into first one constant 0 minus second one e power minus T by RC. That is minus 1 by RC into e power minus T by RC, right? Then see current is how much? Current equal to minus of minus of plus. It is now C gets cancelled. It is equal to E by R, e power minus T by RC. Okay. So we got a charge as a function of time and we got a current as a function of time. So this is giving us the rate at which it is charged. Okay. And this is now charge. And if you plot the graph for Q as a function of time, if you plot the graph for Q as a function of time, it is now increasing exponentially. It comes approximately like this and finally becomes a constant. This is now charge as a function of time. Okay. Now in this, if you are taking t value RC, if you are taking t value RC, okay, if you take t equal to RC, then e power minus 1, right? E power minus 1. And that value will be, when you take t equal to RC, Q will be equal to, see carefully, when t equal to infinity, when t value infinity, this is 0, right? So Q value maximum how much means it is equal to EC, right? How much it is equal to EC, that is maximum charge. Let us take it as a Q naught. Okay, let us take it as a Q naught. See, we have taken like charge Q equal to CV, right? Here E stands for EMF of the battery. Okay, this is maximum charge. When T equal to RC, Q equal to 0.63 times Q naught. That means when in the time interval 0 to RC, charge increases to 63% of the maximum charge. That means it will be charged 63% in the time RC. And this RC is known as time constant. This is known as time constant, or you can say relaxation time, but using frequently time constant. Okay. RC is known as time constant. In one time constant, in one time constant, so it will be charged by 63%. Okay. And here importance of this time constant is if this is less, if time constant is less, that indicates that capacitor will charge more quickly. I am repeating. If RC is less, means time constant is less, that indicates that capacitor charges more quickly. That means if we choose R value less, it will charge more quickly. If you take R value more, it will take more time to charge. Okay. Next, coming to current and see carefully current when t equal to 0. When t equal to 0, this exponential becomes 1. That means when t equal to 0, condition is here charge is 0 on capacitor, means initially uncharged. Okay, initially uncharged. So when t equal to 0, I equal to E by R. See carefully. This is just like as if there is no capacitor. What will be the current? You just imagine here. There is no capacitor. Okay. So what is the current? It is simply E by R, right? If there is no capacitor, current how much means simply EMF by resistance. That is what we got here. So here we conclude that when capacitor is uncharged, initially it is just like a conductor. That means no need to consider capacitor. So current equal to E by R. Now see carefully when t is infinity means after long time this becomes 1 by e power infinity, right? If I am taking t value infinity, it is 1 by e power infinity. That means current equal to 0. Current 0 means it is now fully charged. When capacitor is fully charged, there will be no flow of current. The meaning of that I equal 0 is there is no flow of current once it is fully charged. Okay. That means initially what happened is once we're closing the switch, it will be current flowing means it is now charging. So charge keep on accumulating on the plates. And once charging is over, there is no flow of current, right? So these key points we are going to use while solving problems. That means uncharged capacitor initially acting just like a conducting wire. It is just like a conducting wire. And fully charged one, it will not allow any flow of current, right? So this is about charging of capacitor. Okay. How charge is changing Q equal to Q naught into 1 minus C power minus T by RC. Okay. And coming to current, E by R into E power minus T by RC. And graph will be like this, right? And you can see here from the graph, slope of the graph is decreasing. If you observe, slope of the graph is decreasing. Slope is decreasing means the current is decreasing. So current decreasing means the rate at which capacitor charge is decreasing. That means initially capacitor is charged faster. Initially it is charged faster. As time passes, rate of charging will be less. The meaning of less slope, less current. It is charged slowly as time passes. So charging is done faster initially, right? The meaning of a slope is decreasing. Now focus. Now focus discharging. Let us focus now discharging. Discharging means initially capacitor fully charged. Now connecting that across a resistor. Now there is no battery. Okay. Initially it was a fully charged. Let us take charge equal to Q naught initially. Resistance is our capacitance C. So once we are connecting, what happens is, since it is initially charged, there is energy stored in the capacitor. Energy stored in the capacitor. Once it is connected to resistor, charge flows like this. If it is a plus and this is a minus, charge flows like this. That means there is a current flow. And because of the current across a resistor, energy will be lost. Or if you call this as a bulb, we can see a bulb glows here. So loss of this energy appears now across the resistor. The meaning of discharge. Especially we can see the uses of RC circuits. Suppose we are taking a turning on a vehicle, maybe it is a two-wheeler or a four-wheeler. While taking turning, we are giving signal, and we can see that is now blinking, right? When you are giving signal while taking turning, that is blinking. That is nothing but application of RC circuit. Charging, discharging, charging, discharging. Discharging means a bulb glows. Okay. The applications of RC circuits. Now see here how charge decreases as a function of time. So if I am taking Kirchhoff's second law, suppose the current is I. Kirchhoff's second law, we are moving along the current flow. I am taking anti-clockwise. So we are moving along the current flow. So take minus IR. Next, low potential to high potential plus Q by C, where Q is charge on the capacitor at one instant. It is charge on the capacitor at one instant. Now see what we can write here from here. So we can write IR equal to minus Q by C. Now from this, see in the place of I, what we have to write. Since the charge is decreasing, here I is nothing but minus dq by dt, because q is decreasing with the time. Therefore, dq by dt itself is negative. So negative of negative positive. Okay. So here it should be minus dq by dt, that is equal to minus q by rc. Minus gets cancelled. Now see what we can do. dq by q is equal to T by RC. Check it once. dq by q equal to, sorry, it is dt, right? dt. It is a dt by RC. Now integrate. Okay. So limits 0 to t. When time t0, charge was q naught. At time t, charge is q. Now see the remaining calculation part. It is ln q. So ln q by q naught, that is equal to, see once in calculation here, minus IR. Wait, I think I made a mistake here. Minus, it is a plus. So here it should be minus, it should be minus here. So it should be minus T by RC. Okay. So small mistake here. It is minus IR plus Q by C equal to 0. Then IR equal to Q by C, right? IR equal to Q by C, not minus. So we get here minus. It is now Q equal to Q naught e power minus T by RC. Okay. See how graph comes. It is now exponentially decreasing. It comes approximately like this, approximately. Right. And if you want to calculate current, calculate now minus dq by dt. See how much it is? Q naught. It is minus 1 by RC. Already we have taken minus here. It is 1 by RC into e power minus T by RC. In the place of Q naught, see earlier what we have written? Q naught equal to EC, right? EC. So it is equal to now EC means it is now E by R, E by R, E power minus T by RC. So again current is same, right? I equal to E by R into E power minus T by RC. So when we are taking T value 0, T value 0, this becomes now 1. So I equal to E by R. And if you take after a long time, means T value infinity, there is no current. Its meaning is capacitor is fully discharged. Its meaning is capacitor is fully discharged. That's why there is no flow of charge. And again here, if we take T value RC, means one time constant, charge becomes now 0.37 Q naught. Okay, that means in one time constant, it is discharged by 63%. So remaining how much? Only 37%. So while charging in one time constant, it charges by 63%. Here it is, it will discharge by 63%. So this is the present value, means 37%. Okay. So this is regarding charging and discharging. Okay. Let us take now one simple question. Take one simple question. I take one small question here. Let us take a capacitor and resistor C, and this is R. Take here one more resistor parallel to that combination RC. Now we are connecting to a battery. There is a battery. Let us take it has some resistance. It is also R. This is R, and switch is like this. Now question is, initially capacitor was uncharged. Initially no charge on the capacitor. Now when we close the switch, okay, so question is that at t equal to 0 means just after closing the switch, what is the current? What is the current through the battery? Okay, question number 1. Second one is at t equal to infinity, its meaning is after a long time, what is the current through the battery? Okay, so it is condition is that capacitor was initially uncharged. Now when we close the switch, just after closing the switch, what is the current through the battery? Next, when t equal to infinity, what is the current? Means after long time, what is the current through the battery? Okay. So here now we are going to use the results which we have got in charging and discharging. So when t equal to 0, that means we have discussed that when t equal to 0, no need to consider now capacitor. No need to consider capacitor. It is just like a conducting wire, right? Because we got result like I equal to E by R into e power minus t by RC, right? While discussing discharging, we got current like this. And there we got conclusion that when T0, I equal to E by R. That means capacitor has no role just after closing the switch. So here what I can say is just after, just after closing the switch, current is now flowing, or let us take here, yeah, current is now here. What happens is it is just like conducting wire R and R. These two are now parallel, right? So these two are parallel. It is R by 2. Now that R by 2 and R, that will be now in series combination. So it is now what we can say is just after. Let us do one thing to avoid confusion here. Let us take a simple circuit without resistor here. Right. Now take here only capacitor. Only capacitor. Right. Now see carefully. There is no resistor. Right. So now here, just after closing, there is no current, okay? Means across this, there is no current, sorry, this is just like a conducting wire. That means I equal to E by R. I equal to E by R because this is acting just like a conducting wire. That is what we are saying from this result. This is when T equal to 0. Now, if you are taking after long time, if you are taking after a long time, what happens is it is a fully charged. When this is a fully charged, now current flows only in this way. There is no flow of current like this. That means after a long time, current will become, it is E by 2R because the current flows, it is like this in this way. Just after closing switch, it is just like a conducting wire, just like a conducting wire. That's why it is a conducting wire. So current flows like this. So conducting wire means across this there is no potential difference initially. So it is equal to E by R when T equal to 0 just after closing. After long time it is equal to E by 2R. Okay. So like this we are taking the application of this one, right? So in the next lecture we can discuss some more questions basing on this.